In this example, we're going to do a second finding the inverse slope by using calc. This is our formula that we're going to use. So we're going to be looking for an inverse slope at a particular value. So here's our situation. Now that's the b value. So when we do this, our final answer is eventually going to be 1 over f prime of an a value. We have a b value, which means, if you remember, if you were to have some sort of original function. You plug in an a value, you get a b value. An inverse is backwards. B value gets an a value. So when we're starting off with a b value, we need to figure out what a value created that zero. And so then I can sub it into this. All right, so we have this quadratic, and we are limiting it because of the inverse would not be a function. So if you were to graph this, you would see this x value being the vertex, and we would be graphing the right side of this graph, not the left side of this graph. So we would be kind of the parabola, but it would be just the right side if we just limited it to that domain. So we're going to use that information. So the first thing we're going to do is we have our b value. We need to figure out our a value. So we're going to take this equation, this x squared plus 3x minus 4, and we're going to set it equal to this b value, right? We need to figure out what's the a value that created the b value. So this is factorable. So we got x plus 4x minus 1 as the factors. So the solutions are x equals negative 4, and x equals 1. So we don't want that one because that would be the other side of the graph. So we're looking for this one. So we're going to kick that one out. And this is our x value. So we need to figure out 1 over the slope at 1. So the next part of this is, let's find our slope equation. So our slope equation is going to be 2x plus 3. We'll sub in the 1. So 2 times 1 plus 3. And that's going to get us a value of 5. So our inverse slope at 0 is going to be 1 over 5. That is how we find an inverse slope.